check that. Now, here's what you need to know. In this case, once we did the first one, the second one, we should never even have done. So let me tell you why. And someone asked a question first hour, didn't ask it here, so I'm going to tell you. When you're solving a system, you're looking at when two lines cross each other. Now, if you already found one solution, that means like the point where they cross each other. Do you think those lines are ever going to cross each other again?
No.
No. So if you're looking at a system of linear equations, there can only be one solution. Okay?
Wait, can you say that again?
When we're solving a system of equations, we're looking at where the two lines cross each other.
Yes.
They can only cross each other one time. So will a system ever have more than one solution?
No.
Not if it's linear. Okay? If the if the two equations are linear, then you should only have one solution. I'm saying that so that you're careful because sometimes you won't get a system where it's two linear lines. Right now we will, but later on you're going to graduate to more tougher stuff. Yes?
So meaning if it crosses once, then it's a solution. Just one time.
It's the solution. The crossing point is the solution we're looking for.
But if it crosses more than once, then it's not a solution.
Will they?
No.
So will you ever get more than one solution?
No.
Correct. When will you ever have two solutions?
Are they going to tell us in the problem?
No.
If it's linear?
No, they won't.
Quit.
That's for you to decide. That's why I said make sure that you know what these equations look like. Because if they give you a quadratic equation, it looks like this, doesn't it? So if I have a quadratic equation with a line, how many solutions would I expect to see? Two. Make sense? Good. What if I had a circle with a parabola?
No.
Four. 1, 2, 3, 4 solutions. Okay? If I had two circles, how many solutions would I expect to see? Two solutions. So you have to kind of think about that and understand what that is, okay?
But they won't ever give you like a heads up. Like,
No.
no.
No, they'll give you the equations and you have to understand what they are. Okay, and we'll talk about it in a minute. Because that could happen, right? If the two circles don't touch each other,
No solution.
or if you have a circle and then there's a line that's over here on this side,
There's no solution.
there's no solution. So
they don't intersect,
if they don't intersect, then there's no solution. Makes sense.
Can we give a shout out to Liliana?
I think you just did. So let's move on. Okay, so this is checking the other one. One was true, one was false. Now,
I think you just did.
solving systems by graphing. Solving systems by graphing. How many people already have their calculator? Good. You're going to want to have one. How many people have a calculator? Good. Make sure you have batteries in your calculators. I'm going to show you at the end how to do all this, okay? But I also said you still have to make sure you know how to do it by hand. Because sometimes it's just faster to do it by hand than it is to punch stuff in your calculator. Okay? So, moving on. Here's this example. They want us to solve this by graphing. There's a couple ways you can do it. I'm going to use, I'm going to put both of those into slope-intercept form. Is that cool with everybody?
Yes, sir.
So that should read y equals negative 2x minus 5. And the other one should read,
Y equals
let me use another color here. So that's going to become 3y equals x plus 6. Divide everything by 3. So the other equation is y equals 1/3 x plus 2. Okay?
Because you divided it.
Right. I divide everything by 3. Okay? So, let's look at the top one. Top one says my y-intercept is a negative 5, which is right here. And to get to the next point, let's see here. I'm going to actually use this in reverse so I can get some points, okay? It says down 1 to the right 2. I'm going to go up 2 and back 1 so I can get some stuff. So 1, 2, and back 1 is right here. Up 2, back 1 is right about there. Up 2 and it's right about there. Up 2. I'm just going to try to use up all my spaces here. So that's that line right there, the one in red, okay? Is that cool with everybody?
No.
It's not, no?
No, I do it. You have to draw the line.
You just
Yeah, you have to draw the line, but I'm not going to because
You
it's
just
not
go
going to mark it
over
on
two,
top. What?
Because it's negative 5, 2,
So-
negative 2, so it's negative 5 on the line, and then you just go over negative 2.
Look, here's what I did. This says down 2 to the right 1, right?
Yes.
But the top one have to be negative?
Yes.
No, that's my preference, okay? Because I can't go down 2 and to the right 1 on this graph. That would put me out of there, wouldn't it? Like over here
Yes.
somewhere? So that would be, look, not good.
So you can go up.
So I'm using this in reverse. Instead of being that negative, I'm going to go 2, negative 1. So from this point, I go up 2 and back 1. See it? Up 2, back 1.
Oh.
Does that make sense now?
Yes.
Good. So
It's
let's,
still the same thing.
it is exactly the same thing. I'm gonna get rid of this just because it doesn't match. It's not calibrated very well. So I want to make sure I get this correct here. Now, let's do the second one. The second one says I got a y-intercept at 2. At 2. And this says up 1 to the right 3, right? Now, I'm going to do opposite of both of those. So I can go the other direction. And why want to go in the other direction?
So you don't go off the page.
Because I have to cross this line.
Yes.
Like, if I just went up 1 to the right 3,
You're never gonna cross the line.
right, so I got to go the other way. So if I'm going up 1 and to the right 3, I'm going to go back 3 and down 1.
Oh, hey.
And 1, 3. Ah, look. Do you see where the two lines cross each other?
Negative 3, 1.
Where was it? Negative 3, 1. Boom, there's my answer.
Negative 3, 1?
Yeah, we're done.
Isn't it just right
Plug
there?
it in. Math.
Negative 3, comma 1. That's the solution. Yeah, so you do want to check it. Make sure that is correct. So, can I get rid of the math up here?
Yes.
Yeah.
Wait, no.
That's too late for that.
Control Z.
So let's check it. 2 times x plus y has to be 5. Negative 3 goes here. 1 goes there. That's negative 6. Oh, should be negative 5. Plus 1 equals negative 5. Does negative 5 equal negative 5? Good, so it works there. Let's try with the other one. The other one says negative x plus 3 times y should give me 6. That's a negative 3. That's a 1. Negative negative makes a positive 3. Does 3 plus 3 equal 6? Does 6 equal 6? So we're good. Answer is absolutely correct. I don't have to be like, Mr. Munoz, can you come check this? Because I know. I got 100. We're good?
Yes.
Questions there?
No.
Awesome. Moving on.
Are we going to do another problem like this?
No, graphing, you should be able to graphing. You've done graphing all of algebra 1. You did a lot of it during second year algebra. So you should be able to do it, okay?
Yeah.
So first year algebra, second year algebra. There's the lines. Oh, cool. Awesome. Moving on. Okay, I want to talk about this line real quick because I think this is something you were asking about, okay? Take a look at these two lines. These lines are called intersecting. They only cross one time, right? So it has one solution. Any system that is intersecting is called a consistent system if it has a solution to it. It's consistent. Okay, understand those two words. There's consistent and there's going to be inconsistent. Guess when you get an inconsistent system? When there is no solution. If there's a solution, then it's consistent. No solution, it would be called inconsistent. For example, two lines that are parallel. Will they ever cross each other, Cambria?
Sorry, you said something about here.
Will two lines that are parallel ever cross each other?
No.
So will it ever have solution?
No.
That's why it's called inconsistent. Now, over here, you see one line, right? Well, it's not really one line. It's really two lines.
But they're just converging.
They're on top of each other. That's called coinciding. It's called coinciding.
Coinciding?
Yeah, it's a coinciding system. It's a consistent system because there's solution, right? Now the question is, how many solutions does this bad boy have?
2.
Infinite. Because every point crosses itself, doesn't it? Okay, if the two lines are on top of each other, they're crossing each other forever. So that will have infinite. Okay? One, none, infinite.
1.
Pregunta.
Infinite.
On your test, I was gonna have any ones that.
Yes, you will have anything. Anything that I teach you or that you've been taught all the way from kindergarten is fair game.
Kindergarten?
Yes.
Yeah, I understand, but are we going to be able to tell the difference of the lines? Because I can't even tell that there's two lines there.
Well, they're not going to give you two lines. They'll give you two equations.
I don't even know.
And then you have to figure out whether it's consistent or inconsistent. Okay? Yeah, they won't give you a graph and be like, if they do, they'll say,
Freaking rude.
shh, guys, you really want to hear this because it's a great question. Shane, can you take the headphone out? Thank you very
There's
much.
nothing playing.
That's okay. It just kind of
It's
bugs me.
comfortable.
You know it bugs me. Off with your headphone.
Obviously off your head.
Yeah.
That too.
When you just pulled out a sword.
No.
You can push the stick.
The sword's been easy, man. It's lightsaber. If they gave you a graph, Alberto, they would say the graph, the following is the graph of f and g function. So they would tell you that it's 2, even though it shows you one picture. Then you would say, oh, if it's showing me 2 graphs, then what's going on? They're on top of each other. Does that make sense?
Yes.
So in some way they'll tell you if they do that. Okay, they have to. Otherwise, even I wouldn't be able to figure it out. Okay? Thank you. All right, let's solve systems by substitution. This used to be my favorite one. You're really bad at this one?
Me too.
This one's the easiest one.
I'm bad actually.
So let's get to this.
Okay.
Okay. To what, that?
So remember asking for the added.
All right. Okay, so let's start with this one. Ready? I have a question for you. What does x equal? What does it equal?
2 negative y.
2 minus y. Oh, that's an x, isn't it?
Yes.
So I'm going to take this and substitute it in there. So 5 times 2 minus y minus 3y is equal to negative 6. I'm going to use my distributive property.
You're going too fast.
You just plug in X.
Okay, Cambria.
5
Do you see how that's 5x minus 3y equals negative 6?
Because
It's
you
just,
got rid of the x's because you minus them, right?
no, I substituted. I did not minus them. And the proper term is subtract.
Subtract. You said all the way to kindergarten.
What? But she waited to have a question.
The whole bar.
Do all your exes live in Texas?
So I substituted that in.
So where's the x go?
Munoz, uncolor your X so you can see.
Why?
I think she's confused on that. See how X equals 2 minus Y?
Oh, it said, never mind, got it.
Yeah, I think she didn't see.
You could have said you're plugging it in.
I did say, I didn't say plug it in, I said substitute.
The reason why she got confused was because you were Xing out the X.
Yeah, that's why I got confused. Because I was like, why
I'm going to move on.
Why did you do that?
I'm going to move on so we can get through this.
Okay.
Are we good now?
Yes.
5 times 2 is 10. 5 times negative y is negative 5y. Minus 3y equals negative 6. So I just wrote exactly what was there before, but I used my distributive property to expand that first part.
2y.
I'm going to combine these two. So I've got 10 minus 8y, and that equals negative 6.
Minus 10, minus 10.
Correct?
Divided by 8y.
I'm going to move this over, and it's going to become a negative 10 on that side, correct?
Yep.
No, wait. You're supposed to subtract.
Is that not what happens when I do that?
Negative 8Y
Right?
equals.
Why do you put it on the other side?
Yeah.
Let's get the y alone.
Because we're trying to get y by itself,
Or don't
remember?
you subtract it or something?
Isn't that what's going to happen anyway?
That's what he did.
It's a shortcut. It's called change side, change sign.
Entiendes, Bendit?
If I have something on one side, Cambria, and I want to move it to the other side of the equal sign, I can change a side as long as I change its sign. So it was positive here.
But how do you know when to change it?
Do I want this 10 on that side?
So you're going to minus negative 6 minus 10.
Yes. So now I've got negative 8y is equal to negative 16.
Because we always have to get the Y or the X by itself.
I know that, but why didn't you just subtract like negative 8?
Okay.
So I said it's all square.
Here, you know what? It's taking longer than just doing it.
Okay, no, it's okay, just do it your way, just do it your way. It's just a question.
Okay, so there's 10, right? Minus 10, minus 10. 0. See the negative 10 on that side? There's a shortcut, but that's okay. So 8, that's negative 16. Divide both sides by negative 8. What's the value of y?
2.
Y is 2. I'm going to take that
Plug it in.
and plug it in here because what does x equal?
2.
2 minus y. What is those y?
2.
So what's
X
my
equals
solution for
0.
x?
0.
X is equal to 0. Now, I told first hour, I used to do this when I first started doing it. I put my answers in little boxes like that, and I lost all my points.
Why?
I checked them.
Because they're not in a coordinate. They're not
Ordered
in a
pair.
ordered pair.
Yeah, remember I said the answer is an ordered pair.
Yep.
So it's got to be put into one of these bad boys. So the solution is 0, 2. This could be right, but that's not what they're looking for. That's what they want. So if you don't do that in this class, you're wrong. Even though your solutions are appropriate, the solution would be incorrect.
Even if we did that
Correct.
on a test, I'm in, right?
Also on a test, even when you get to college, it's going to be the same thing. It needs to be an ordered set. Concur? Questions here?
So it's 0 because you did 2 minus 2.
Correct. Questions here? How was that? See? It was good, yeah? Now, it's not always going to be that easy.
I think that was the other one I was confused on. I know this is, but it's.
Are you talking about what is three equations?
Yes, that's the one I
Yes,
get so
I hate
confused
it.
on.
Are we gonna do the
Okay.
matrix now?
No. Here's another example where I have to substitute.
Can I do it?
Okay? Now, you're going to have to learn to inspect these. See if there's something you can do. And in this case, I can actually, mira, Cambria. I'm going to move this over there. That becomes a negative 4x. Do you see it?
Yep.
Yeah.
So now I know what y equals. What does y equal?
5 minus 4x.
So where does that get plugged in?
4x. Oh.
So 2x minus 3 times y is equal to 13. And I just said y equals that.
So
I'm plugging it in.
Oh, I get it.
Solve it for x.
But can I watch you do it and then I write it down?
2x minus 15.
I'm not going to do the rest of this. I think you guys are okay here, right?
I
Yeah.
can read it.
Can I write it down quick?
Yeah, go for it. But you should be able to do this from this point, right?
Yeah.
You got it?
Does anybody need me to do it?
I want Cambria to try it.
Okay, now once you get your x value,
Let's see.
plug it back in there. Because this is what y equals,
Let's see.
right? Y equals, oh, I didn't pick up a marker. Y equals all of that. So make sure you plug your solution back in there. Okay?
Nice.
Thank you.
Oh no, there's an error with the playback.
Ileana, something weird to watch.
Oh, you know what? That's probably my
X equals negative 14.
That times out.
Oh, real
When you have
stuff.
x equals negative 14.
I'm gonna
X
look
equals
at
negative
John's
14 or
notes.
something.
Shut up.
I think you have her notes.
What? But you helped me.
She should still be on. Okay, questions there?
So okay, wait, can I ask one question?
Of course you can. You can ask any
So
questions.
for the negative 3, I times it by the 5 and the 4.
4x.
Negative. Yeah, you distribute that.
So I might.
Yeah, you time and you ignore the 2x times it. Or you do
Or
that.
since
Here,
I
let me
was
just
in
do it.
kindergarten, we multiply. I was right. That's what I asked.
That becomes a 14x minus 15 is 13. I need this to be on the other side, right?
Yeah.
Is that correct? So that's going to become a positive 15 over here. So 14x is equal to 28.
So it's 2.
So x is 2. What does y equal?
So you combine the 2x and the 12, right?
Correct.
Is it a negative 12 or no?
Does it say negative?
Oh,
No, because negative, positive.
Oh, y
Y is negative 3.
negative.
So it's
Y is negative 3.
I got it.
Questions there?
15x. Wait, I'm trying to figure it out and do it on my own.
Hey, mister, is it always gonna be
So
full?
then
No.
14.
No.
So
So
you
you have
have plug in x. The first one or the second?
Well, this is the x you got, right?
I mean, to get y, where would you?
Which equation?
Yeah,
Whichever one you like best.
it doesn't really matter.
No, but I like this one better because it already says y equals that.
It's easier.
Exactly. But I can plug it in here
Oh, wait, Munoz.
and get the same answer.
Yeah.
Since it's negative
That's a good
15 on
question.
that side, and you want to switch it to the other side, it becomes positive, right?
Change side, change sign. Correct.
And then it's 28 equals
Hey, mister.
14x.
Found this in there.
What?
I found this in there.
I
Cool.
get
Thank
it!
you. Can we take that from me?
Are you happy for me?
Some of these pictures?
Unless you want me to do it later.
So it's a senior
When did we get
packet.
pictures?
Are you
It's a senior
happy?
packet. It's a packet of
I'm
seniors.
happy.
Am I in there?
Mister, is it rare you're gonna find a fraction? Or
No, it's not rare. Fractions are real. They have feelings too.
Yeah, but
They want to be used.
Me.
What?
if you have a fraction,
They're not whole though.
I would leave it as fraction. But yeah, you still have to plug it in and do all that.
Unless it says simplify, then you can get your estimate.
Fractions are okay. As long as you've simplified them correctly, then you should be good. Okay,
Well, it's going towards me.
look here.
Oh,
Whoa, just take it easy, man. Laughing.
Which one would be
Okay.
a better one?
Now, I got this problem. I've got to do it. I don't like those fractions too much.
I just skip
Me neither.
What up? No, that's not
I'll
acceptable.
take the L, I don't care.
That's not acceptable.
I'll take that L.
How do I get rid of the denominator?
You times it by 2.
Times the second
By
Multiply
two.
it by its number.
The LCD, which happens to be 4. So I'm going to multiply this whole equation by 4. So here's what's going to happen. 2 goes into 4 2 times. That becomes 2x. 4 goes into 4. That becomes a y. That becomes a 2.
You just
So
divide
now what I can do is I can just throw this over and I know what y equals.
Wait.
2 plus minus 2x.
What does it make sense?
Because you multiply it by like 2, so the y is still 2.
Multiplied it by
I
4.
multiply
That's
by.
what I meant to say. I know.
Like 4.
Here, let's look at it like this. See my 4 fingers? What's half of those 4 fingers? 2. See the 2?
I see what you mean.
I got 4. I want one of those 4. This is one of those 4. How many fingers am I holding?
Y. Correct
Look at us like, I don't want to.
How did you get 1?
Because 4 times 1 over 4.
Laugh it out, Lucas. Laugh it out.
Sorry.
Okay, we're
I
good?
said Y.
But how'd you get 1?
Right. You're
What's a quarter of 4?
Yep, that makes
Okay. Or, go ahead. No! I don't want to work with decimals either. You could,
Fractions are better
if you
than
want
decimals.
to. Now, you, sorry. You could, but I don't want to. Now,
Do it.
now, shh. I'm going to go and take this opportunity because you guys see what you can do, right? Solve it with substitution.
Yes.
Yeah.
I'm going to take this opportunity to show you. I'm going to show you another method, which is called elimination. Okay? Don't
The process of elimination.
stop. Yes, linear combinations. Now, the way that elimination works is by trying to eliminate one of the two variables, either the x's or the y's. And it's weird because the way we do that is by adding the two equations. And that is totally legit mathematically. Okay? If I've got 5 nickels and 5 pennies, and you got 2 nickels and 2 pennies, can we add those and figure out how much money we got together?
Yep.
Totally legit, isn't it? You see how that works? You did not hear what I said?
I heard you said I start confused.
You got confused?
Yeah. We were talking about systems and then we're talking about money.
Because I was giving you an
I
example.
can only do one math at a time.
The way we,
Those are numbers.
Seriously.
Mister,
though.
so you're gonna add.
so the way, what we're trying to do with elimination, Steve, is we're trying to eliminate, sorry, Steve. Thank you, Steve. Is to try to eliminate x's or eliminate the y's. So that we don't have to worry about one of the two
Oh,
variables. Because here's the deal. Please understand this, and if you don't remember this from freshman year, you need to know this. If you have one variable, you must have one equation. If that one equation has 2 variables, you're not going to solve it. It's not going to happen. You can solve one equation if it's in one variable only. You can solve a 2 equation system, but you have to have how many variables? 2. If you have 3 equations, then 3 variables. So forth, so forth, so forth. So you need to get rid of one of the variables. Now, this is how easy it is. Do you guys see the red equation? That's the same equation as this one, but it's 4 times bigger, correct?
Yeah.
So I can still use it.
And
It's
then
legit.
there's -2.
I'm going to add it to the top equation.
So the x cancels out. Right?
What happens when I take 2x minus 2x?
0x.
Gone.
Nothing.
Y plus 5y?
6y.
6y. What is 22 plus 2?
24.
Divide by 6?
4.
And I'm done with that part. I plug it back into one of the others and I get the x.
Y
Okay.
equals
I need to
4.
highlight that.
So minus
Is there another way to do that? Or is that
x
that
equals negative
only
1.
way?
No, I just showed you graphing and substitution.
X equals
Because
negative
you
1.
know, is this a substitution problem or no?
Damn, I see seal.
This is a what problem you choose it to be. Okay, guys, you need to get over that whole thing where they say Because I know what you're saying. Like sometimes they'll be like, solve this problem by
That's what it said on the.
graphing.
That's what it said on the.
Right?
question.
No, but you know how we just did a substitution problem?
We did the same one with substitution.
Yeah, but alright, so you know how there's a 2x plus y equals 2?
Yes.
I thought you were gonna put that like into where it would be y equals,
Uh-huh.
and then that.
We kind of did. I said, here's where you can go and solve it through
Yeah, but you
substitution.
know how you did that top part where you like mix it together
Right.
right now? I thought you were gonna
Slope
use
intercept.
that 2x, that 2x plus y equals 2. I thought you were gonna do something to that.
Yeah.
And
Yeah.
then.
Check this out. Check this out.
Into the top
Look,
part.
look, 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 look,
I'm
look,
looking.
look, look. I got y right now, correct?
Yeah.
By using that elimination thing. If I plug that into the top equation, that gives me negative 2x. What is 5 times 4? 20?
Yeah.
Right? Equals 22. Take 20 from both sides. That's gone. Negative 2x equals 2, which means x is negative 1. So I'm going to say the solution is negative 1 comma 4.
Yeah.
Okay? Now, I used the elimination method to solve that. Let me get rid of this.
Oh, this is the elimination method.
Mr. Munoz.
Now, this problem is not a elimination problem. It's not a substitution problem. It's how the heck do you want to solve it problem.
Alright.
Okay? So, what you're saying is, oh, we're going to do substitution at this point, huh?
Yeah, that's what I
Y
was
equals
thinking.
2 minus 2x.
And then plug that in for that.
Let's do that. So, negative 2x plus 5 times y is equal to 22. This is 2 minus 2x. So, I've got negative 2x plus 10, right? Plus 10 minus 10x
Yeah.
is equal to 22. This and this is going to give me negative 12.
Wow.
Thank you, 12x. If I move that over, it becomes a negative 10. So this equals 12. So what does x equal?
Negative 1. So it really doesn't matter which way you want to do it.
No, it doesn't. What I'm doing is I'm
That's
teaching you
all.
different ways so that you can do whichever one you like the best.
Alright.
And what I can recommend to you is pick one and get good at it. Once you get good at one, do others. Gabriel.
Are we going to do the 3 equation substitution?
We will at some point. No, not substitution.
That's what the
That's when you eliminate.
You cannot do a 3x3 with substitution. It's not gonna happen.
At Ileana.
Moving on.
Did you ask question on it?
Yes.
I have a question. So let's say you had x's that didn't cancel out. Is there another way to continue doing
Moving on. I'm gonna answer that question right after this next one, okay? Because I want to make sure you guys are getting the feel for this. Here's another example. Do I really want to substitute here, Shane? No! Why?
But you can cancel.
Look at the X's! This is like an underhand toss playing baseball. It's like alley-oop, right? That's 0. 5y equals negative 5. Y is negative 1. I'm halfway done.
Wow, wait, can I write that down? Because that's easy.
Wait, how'd you get this?
I added the 2 equations. So what's 2x minus
Yeah,
2x?
I see it.
Wait, I didn't know you could do that.
You're so
And then it's 7 halves.
Thank you.
It's 7 halves.
My notes are real pretty today.
Okay, are we good?
Yeah.
I would've
No.
never
This
thought-
is easy, but I
Yes.
Thanks.
Of course you can.
can't like
Y equals
Questions here from
negative
anybody? Russell,
Hey, Mr. How will it become like undefined?
we'll talk about that. We'll get to all of it. I promise.
Everybody knows how to do that.
Promise.
I know how to do it with
Okay, do I need to finish this? Or you guys are where to go, right?
We straight.
We're good.
Okay.
What's so funny?
He said every straight, he goes, I'm not.
Oh, I didn't hear you. That was funny though. That is funny.
I just repeated him. I'm not gay.
Moving on.
Yeah, just kidding.
Are we good?
Yes, we're good.
Alright, here we go. Now. Ah! I like substitution, but you're not working for me. And I like elimination. I really don't want to use this for substitution because substitution is going to produce fractions for me. So, here's what you're going to have to do. Ashley, pick a variable. Which one do you want to get rid of?
24.
Let's do y.
Which one?
Y.
Why? Why?
Why not?
Why not? Exactly. That's a fantastic reason. I thought you were going to say because one's positive, one's already negative. Now, here's the deal. We're going to try to get rid of these guys. Okay? Now, remember how I took that fraction equation, I multiplied the whole thing by 4?
Yes.
That's what you need to know how to do in order to do this. So, I need you to think about what is the, and I'm throwing up some air quotes, what is the LCD to those numbers?
21.
21, right? So I need the top to be a 21y and the bottom one to be a negative 21y.
So you multiply the top one by 7 and the bottom one by 3.
So 14,
Absolutely.
14x,
That's absolutely correct.
14.
So here's the question. To make this become that 21, what do I need to multiply it by?
Everything by 7.
But I can't do it to one thing. I gotta do it to the whole thing. So I'm going to multiply the whole equation by 7. 7 times 2 is going to give me a 14x. That's a positive 21, by the way.
33.
And that's going to give me
133.
a buck 33.
Are you gonna multiply the bottom by 3?
Yep.
Yes.
Oh my gosh.
Why? Because I need this to be that negative 21.
Never understood.
I thought you multiplied it by 21 then. Not those numbers.
No, multiply by, not those numbers.
Now that's set up for me to fix, isn't it? What's going to go away?
21.
Yes, sir.
Since that's a negative 7, we don't.
You don't
That
make
top
that
7 isn't supposed to be. We don't times it by negative 7.
Well, that's the thing. This one's already negative, right?
Yeah.
So if I multiply this with a negative 7, that will make it a negative 21. And would they go away?
Oh
No. The objective is for them to be opposites.
Alright.
So it's kind of like, but that would have been true if she would have said x.
Oh, alright.
I would have to make one negative so it becomes the opposite of it. Make sense? Good.
Can I ask you a question?
You can ask me anything you want.
Okay. Well, you see how it says solve the system? I imagine when we get the test, it's going to say solve the system. How are you going to know when to use substitution, when to use elimination?
That was what Shane was asking me. And you know what? It doesn't matter.
You can do either one.
It doesn't matter.
So it's the same thing then?
Yeah, I can solve this by substituting. It's going to take me a lot of substituting.
I thought you like really farted.
You can pick whatever you want. If you wanted to graph these, more power to you. Solving by graphing, substitution, elimination,
I don't know
they're all
about
just
that.
different ways to do the same thing.
Okay. So as long as you do one of them, you're good.
As long as you do one of them correctly, then you're good.
Okay.
So let's finish this up, okay? This is going to make 0. That's going to give me 23x. And that's going to give me
115.
115. Divide both sides by 23. That means that x is 5. Halfway done. Just throw it back into one of the first original equations. Does it matter which one, Shane?
No.
No.
Divided by 25.
What? No, 23.
Oh, I did write a 5. My bad. Divided by 23. Because that's a 23. Thank you, Cambria. Easy?
Wait, how do you 23? Oh, never mind.
What?
Because you added 14 and 9, right? So you get 23? Yeah.
Correct. Yeah.
And then you subtracted 133 into 18. And after that you got 5. Alright.
Hey, Steve.
Yes. Oh, I'm sorry. I was distracted. I was What?
Okay. Move on.
Yes.
I thought you were gonna keep finding it.
Okay, boom. Here's another one. Now, let me ask you this question. How would you solve this system?
Add all of it.
Would you want to eliminate here?
Yeah,
No.
No. Now, I do want to give you a heads up, though. Do you see the bottom equation?
yeah.
Because remember, the other ones, we made them bigger, didn't we?
Yeah.
But wouldn't you want to work with numbers if they're smaller?
Yep.
So always do that if you can. What can I divide all the bottom numbers by?
4.
Let's do that. Oops, that's not a 4 at all. Actually, you know what? I'm going to divide by a negative 4. Because then I can get rid of all those negatives too, couldn't I? Negative 4, negative 4, negative 4. What's that give me? 2x. Oh, that's a y. And that's 6. Whoa!
Equaling.
That's the same equation!
So it's all infinite numbers.
So how many solutions do I have?
One.
Why?
Infinite.
Infinite.
Because it's the same line, which means they're on top of each other. So the answers are at every single point. And I'm done.
Don't change it.
It's null. Nice. Is it making sense? Oh, it's common sense.
Yeah.
I see how you can confuse
So
me.
you wouldn't add them?
No, you wouldn't.
Do I need to do anything?
You don't have to do
Is
nothing
it
because that's a
infinite
small
number?
number.
No matter what you solve for, they'll be solved for boundary spinning in the same theory.
This is too confusing.
Yes.
No.
No.
Because I don't know when to do what.
Because that number's already set up. It's already set up.
You see the top equation?
You can do what I was saying earlier too, right? Move the 2x to the other side and then just plug in.
Yeah.
Y equals.
But you know what's going to happen?
Because it's
What?
simple.
You're going to get that x equals x scenario.
Infinite.
Remember that? Where it's all solutions type thing?
Oh, okay.
Because that's what this is. It's,
So then in this problem, substitution wouldn't work.
you want to try it? You want to see what happens? Let's do it. Why not? So I still want that, right? But here's what's going to happen. Check it out. Oh, where did it go? 6. Okay. So if I took this and I moved it over, y equals 6 minus 2x, doesn't it?
Yeah.
Okay. Then I'm going to plug it in here. So I'm going to get 2x plus 6 minus 2x equals 6.
Here's 2x.
2x minus 2x, how much? 0. So 6 equals 6. Is that a true statement sometimes? It's a true statement all the time. And whenever that happens, that means you have infinite solutions. See how that works? The only time that I would have no solutions is if I got like 8 over here. That would mean no solutions.
How do you get it undefined?
There's no undefined. There's either solution, no solution, or infinite solutions.
Wait, so if you plug that
How do
in,
you put those?
you know how you just plugged it into the top equation? If you
Yep.
plug that into the second one, you get the same thing.
Man, isn't that beautiful? There's like no way you can mess it up, is there?
Yeah.
Leave it to me. That's what he sounded like. All right, cool. You guys good?
So if it equals that number when you do it that way, it means it's infinite?
If this equals this other side,
If that doesn't equal the other side, what would it be?
One solution.
like this one, that would be no solutions. 8 equals 6 is no solution. 'Cause that's a false. That's a false statement.
It equals
False.
How
False.
do you get a false?
Wait, did you finish the problem when you divided it by -4? Because I don't think I got it.
Yeah, this became that. So I just, instead of using this big equation, I used a smaller version of it.
Oh, that's when. Oh, okay.
Does that make sense?
And then what do you do from there?
Well, from there, the first time I just said, oh, that's the same equation as the top one,
Yeah.
which means it's the same line. So that means that it is,
I get it all now.
you get
See
it?
that problem?
Because it,
Yes.
oh, that's already, I'm done.
Why? I'm just clarifying.
Oh, I know that.
Okay, cool.
You really
Okay. What am I doing?
I don't know.
There you are. Okay.
That's lit.
Actually, no. You know what? No, I'm not gonna show you what this tonight.
That's lit.
Tomorrow. Okay, we're done. I'll show you guys how to do calculus stuff tomorrow.
Finally, we're done before 12.
Bye, Eliana.
Bye!
Bye.